Hello everybody, welcome to my channel. Today we will talk about concentration of solutions. To be more precise, we will talk about mass fraction. Actually, there are different types of concentration. Here you can see we may have a molar concentration, mole fraction, and mass fraction. Actually, there are also other types of concentrations, but anyway, today we will discuss mass fraction. So in order to find mass fraction, we have to divide the mass of dissolved substance to the overall mass of solution. We divide it to the overall mass of solution and then we multiply it by 100 in order to find it in percents. If we do not multiply it by 100, then we find it in like particles, parts per 100, we can say. But usually it's desirable to find it in percents. Okay. Let's go. Let's see the examples. So omega, this is the mass fraction, equals mass of dissolved substance divided by mass of solution. When we say mass of solution, we mean mass of a solute and a solvent. Solvent is the phase inside of which the substance is dissolved. Solute is the substance that is added to this solvent in order to get a solution. For example, we take water, we add sugar. We want to prepare a glass of sweet water. In our case, water will be solvent, sugar will play the role of a solute. Let's take one particular example. This is, you can see, this is our glass, we have water inside, and here we start dissolving 5 kilograms of, let's say, sugar. We will call it solute. Our sugar is solute. So let's just assume that we have 5 kilograms of water and we add 5 kilograms of sugar in our water. But, for example, not all the 5 kilograms are dissolved. Well, as you can see, mass of water, we write it as 5 kilograms. Then, each of these, I say 5 kilograms of sugar. Let's suppose that every red spot is 1 kilogram, just to simplify it. But not all the 5 kilograms are dissolved, but only 3 kilograms of sugar are dissolved. We write mass of salt is 5 kilograms because we added 5 kilograms of sugar. However, only 3 kilograms were dissolved. Let's now draw it in the picture. I will just color the dissolved ones. They will become black. So the black particle, these are dissolved kilograms. 5, 4, 3. So they are dissolved. And 2 kilograms remain. It means that the mass of dissolved substance will be just 3 kilograms. In this case, we see that solute and dissolved substance is the same thing, the same substance. However, solute is the overall mass that we add. But dissolved substance is only the dissolved part. And yes, here we should add, we multiply it by 100%. Okay, let's now calculate the mass fraction of sugar. So omega equals mass of dissolved substance, and we know that it was 3 kilograms, so let's write here 3 kilograms. Okay, we divide it by mass of solution. Mass of solution will be mass of water and solute. Mass of water is 5 kilograms, mass of solute is also 5 kilograms, so we write 5 plus 5. It means we have 10 kilograms of solution. And as a rule, we multiply by 100% in order to get it in percents. And now, if we calculate it, we will get the answer 30%. It means that the mass fraction of sugar in this water is 30%. Good. Well, let's now take another example. Let's now imagine that we have water, 9 kilograms of water, and we dissolve there 1 kilogram of sugar. In this case, it will be completely dissolved. I will draw it with spots like this pink spot. We assume them like 1 kilogram of sugar. This time it is completely dissolved. It's not like in the previous example we took 5 kilograms, only 3 were dissolved. In this case, 1 kilogram is completely dissolved in 9 kilograms. So mass of solute and mass of dissolved substance will be equal. It will be 1 kilogram. And now we can find mass fraction. Omega equals, so mass of dissolved substance, so 1 kilogram is completely dissolved, we take 1, divided by mass of water plus mass of solute. 9 plus 1 will be 10, and we multiply it by 100% in order to find it in percentage. Okay, and if we calculate, we will find that we have 10% of sugar. So mass fraction of sugar is 10%, hence there will be 90% of water. We can take 9 divided by 10, multiply by 100, we will get 90%, or we can simply take 100 minus 10 and we will get 90%. This will be mass fraction of water. Well, and now let's turn to another example. Let's now assume we need to prepare a solution, and the mass of this solution should be 200 grams. So we need to prepare 200 grams of a solution. And let's say it will be a solution of salt. We need to prepare salty water. And mass fraction of salt should be 20%. So we need to prepare 200 grams of 20% solution. What should be the mass of salt and the mass of water that we need to take for that? Let's do now our calculations. So we'll return to our formula. We say omega equals mass of solute. In our case it will be salt. We need to find it. We don't know mass of salt. And we divide it by the overall mass of solution. We know that mass of solution will be 200 grams. So we write 200 grams and multiply by 100%, and it will be 20% as is given. So now we can calculate mass of salt. So 20%, okay. Let's now calculate. So mass of salt will be 20 times 200 and divided by 100. In this case we will get 40 grams. So mass of salt that should be taken for preparing 20% of 200 kilogram solution will be 40 grams. What about mass of water? So mass of solution is 200 grams. We overall need to prepare 200 grams. 40 grams will be for salt. So in order to find mass of water, we just simply take 200 minus 40. So mass of water will be 200 minus 40. It will be 160 grams. So in order to prepare 200 grams of salt solution with the mass fraction of salt 20%, we need to take 40 grams of salt and 160 grams of water. That's it. So that's all for today. If you have questions, you may ask me, you may write it in comments. I will answer you. Goodbye and see you in the next videos.